Hello, my name is Mr. Chu and I welcome you to my study room. If today is your first time, then I want to strongly encourage you to subscribe to my channel for more videos. Our study for today is on the nature of roots of a quadratic equations. In my previous videos on quadratic equations, I said so many things as an introduction to it. For example, what a quadratic equation is, what the roots or the solution sets are, and so on and so forth. So I want to encourage anyone who missed those pieces of information to check on my videos on quadratic equation to catch up with us. So today our main lesson is going to be on the nature of roots of a quadratic equation. And like I said in those videos earlier, the roots or solution set of a quadratic equation are the x values that we get after solving the quadratic equation. And I remember very well saying that these values mostly are 2. These solution sets have different characteristics, and this is the reason for our study. Let's go straight into the lesson and then discuss those things. Thank you. We have established a very solid foundation already that a quadratic equation of the form ax squared plus bx plus c equal to 0, where a is not equal to 0 is the general form of a quadratic equation. Roots can be obtained using different approaches, which include a general formula x equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. When we pick the a, b, and c and we fix them into the formula, this is going to give us the roots of the quadratic equation or the solution set like we learned earlier. The aim of today's lesson is how do these roots or solution set, how do they behave, how do they look like? That is what we mean by the nature of the roots. How do they look like? And this one, we are just trying to ask, the roots, are they different? Are they the same? Are we going to get any real number at all? Those are the questions this topic aims to answer. And before we go on, we have to take a very important point here, which is when you look at this formula, we take what is in the square root. What is in the square root, which is b squared minus 4ac. This is called the discriminant. And I tell my student that this is called a discriminant because it discriminates the root. It differentiates how one root look like from the other root. So just explaining it to them that the word discriminant is just because it discriminates. It tells how different one root is from another. And in this case, that is what we are saying, that it determines the nature of the root. So basing our understanding of what the discriminant is, which is the part of the equation that is in the square root, let us now delve deeper into what the nature of the root will look like. We have two main types of roots. and these are whether the roots are real. So this is real roots or the roots are complex. So those are the two main types of roots. When we are just finding out whether the roots of the quadratic equation we are going to solve, whether they are real or they are complex. Real means that the roots involve real numbers, and then complex root means that it involves complex numbers, which most students in the senior high school level might not have heard about yet. That is what, when you do it on your calculator, it gives you I and things as answers, right? But that is not all. We have two main types of the real roots, and these are whether the roots are different, which we call distinct. Distinct means different, okay? For instance, we have x being equal to 2 and 3. Those are the solution set to the equation, or 3 and 5, or 1 and 2. Since the first number is different from the second number, then we are saying that these are distinct roots, because they are distinct just means they are different roots, and they are real numbers. That's why we say they are distinct or different real roots. Some will say real and distinct. It's anyhow you put it. It just means that they are distinct, they are different roots. Then the second one is repeated or equal roots. Right. I am just adding the real root to it just to mean that they are under real root. But we can just say they are distinct roots, they are repeated roots. Yeah, because they are real numbers. If the question just telling you that the equation has real roots, then there are two conclusions we can reach. You can not just conclude that because they say it has real root, it means that it has only different root. No, because the repeated roots are also real. That is what it means. And in my next lesson, I'm going to take us one by one through what is expected of us when we are asked to answer a question like find the values of p. That will make the equation x squared minus 2px plus p plus 2 equal to 0 have equal roots. In my subsequent lessons, we are going to delve deeper into each of these one by one. For example, when you are given a quadratic equation with a missing part and they ask you to find the number that will be there for the equation to have real roots, just real roots, or the number you should put there so that the equation will have real and distinct roots, the number you should put there so that the equation will have real and repeated roots or repeated real roots, or the number you should put there so that the equation will have complex roots. We'll take each of them, what they mean, and how we can get those answers. And this is where we end today's lesson. Thank you for making time with me. I hope you have enjoyed it. If yes, why not subscribe for more videos so that anytime I upload video, you just get it straightforward. Thank you and meet you again. Bye bye.